So my name is Rich, and work for a company that gets a lot of DDoS attacks. I do a lot of stuff related to DDoS and network security, and this vulnerability got released about 6 months ago, and the the vulnerability is related to encapsulating traffic. Um, and then there are various types of attacks that you can do with this encapsulated traffic. But first, I'm just going to give like a brief overview on DDoS amplification attacks. So in a DDoS amplification attack, the attacker is able to spoof the source IP of the victim. They say the victim is quad one. The attacker will spoof that quad one, go and then send an amplification request, a request packet to a open amplifier. And so these can be open DNS servers. We see that quite a bit. Open NTP servers. There are vulnerable HTTP middle boxes like censoring things like the Great Internet Firewall, the Great Firewall of China, like other firewalls that will say like, hey, you can't go to this porn site because it's being blocked. A lot of those devices do not check the state, and so attackers have been using those to generate amplification attacks. Also, even a TCP stack can generate an amplification because the attackers can send a SYN to an open TCP server, and then it will send back a SYN-ACK. And if it doesn't get an ACK, it will send back another SYN-ACK and another SYN-ACK. And so, even with TCP, it has this small amplification factor, and some devices, some TCP stacks will send out like hundreds or thousands of SYN-ACKs back. So there can be a large amplification factor there. There is a researcher named Christian Rousseau who did a paper called "Hell of a Handshake." If you're interested in more details about that attack. So the attacker, they're able to send the spoof traffic, goes to these amplifiers, and then the amplifiers send the large volume of traffic down to the victim. And I have a nice animated picture of that, but you can't see it. So how do these attackers find these networks that they can do the spoofing from? There are numerous ways that they can do this. A lot of times they trade this information online. They will, there will be somebody else that's scanning around looking for networks that can do spoofing. They get the list, and then they can sell it to these attackers. A lot of them will run DDoS stressor or booter sites where you could, as say you want to cheat at an online game, you can just figure out the IP address of the user, normally via voice over IP or something like that, and then you can put it into these booter / stressor site, and that they will do the amplification attack to that victim IP. There is a project called the Spoofer Project that's out of UC San Diego, and they are trying to identify networks that can do spoofing to try to get the network operators to fix the issue. But the attackers are actually using this information as well. They're like, oh wow, okay, they see that this network, this hosting company allows spoofing, and they're like, okay, I'm gonna go set up my DDoS stressor website there, and now I can send spoof traffic. So this is for an attacker, this is really great, especially if you want to set up this stressor booter service. It doesn't cost you anything other than running, buying some hosting capacity, like a VPS or something, and very easy. You can make lots of money. As long as the authorities don't find you, people have made lots of money, unfortunately. So in the community, we have been trying to trace back where these DDoS attacks come from, where this spoof traffic is coming from. And, it's easy to trace back if it's a true source IP that's coming in, but if it's spoofed, then you have to dig through your traffic logs like NetFlow records and then figure out where it came from, which interface it came from. And then you see, oh, it came from this other upstream ISP. So then you need to contact them and say, hey, would you please look into your logs and see if you can figure out who sent that? Was it on your network or was it someone behind you? And you have to, and this is kind of a manual process. It's very tedious. We have been making some progress at this. Sometimes, you contact another company and like, hey, we see the spoofing coming from you, and then they just ignore it. And they're like, this isn't our IP. We don't know what the heck to do. Sorry, we can't help you. But there are a lot of good networks out there that are doing a good job and trying to help. So we have been working at this for a few years now. We've actually made some progress, and you could see the graph of this amplification traffic. It's just been going up since like the year 2000. It's just steady increase, and then as we've been doing this traceback, we've seen this decrease. So we see attackers switching a little bit more to using botnets, residential proxies, stuff like that. But the amplification traffic is still out there. It's still a really big problem. But we have made some progress globally. But there is this big tunnel vulnerability that is recently announced. So this is released by two researchers, Angelos Beditis and Matthew Van Hoof. I hope I am probably butchering their names there. They're out of the KU Leuven in Belgium, I believe, is the university. And it's called Haunted by Legacy. I have a link to the paper here in the slides. But there are numerous vulnerabilities that they described in the paper, but I want to focus on one specific vulnerability, and that is the vulnerability where you can send spoof traffic using this tunnel vulnerability. And the vulnerability, it affects, this is GRE, IP and IP, 6 and 4, 4 and 6, and GUE, which is, I had never heard of GUE as a tunneling protocol, but I guess that is a valid tunneling protocol. Okay, so the spoofing vulnerability is that the researchers, they realize that you could, if I try to send a spoof packet from my laptop here to go out to the internet, it would be blocked. Hopefully they're doing a good job here at DEF CON, and they're like, nope, sorry, you're not allowed to send that out to the internet. So that would be dropped. But if I took that packet and I encapsulated it, say in GRE, the spoof traffic, and then sent it to a vulnerable device, then that device will de-encapsulate it and then send the spoof traffic out. So this is unfortunately is a very, very big vulnerability, and I believe that it's going to cause a lot of problems in the future. So in affected devices, you have Cisco routers, Cisco switches, Juniper, VPN servers. There's ISP home routers. There are lots of different devices that are vulnerable to this. And I have a picture here, a animated slide that shows how the attack works, where the attacker is creating this spoof packet, encapsulates it in GRE, sends it to the vulnerable router. The vulnerable router removes that GRE encapsulation. Then it gets sent to the amplifier. The amplifier then amplifies the attack traffic, and then it's sent down to the victim. So the researchers found that there were 4 million vulnerable hosts on the internet. 4 million. And out of those, 2.3 million specifically can send spoof traffic. And I have a link there to Shadow Server. Shadow Server is an organization, like a nonprofit that scans the internet looking for vulnerable hosts to these different things like this tunnel vulnerability, a lot of other issues, and they provide that information for free to organizations. So if you are operating a network out there and you want to get free information about vulnerable devices on your network, contact Shadow Server. But they have a map that shows where these vulnerable devices are. They're spread all throughout the world. There are 11,000 different autonomous systems that are out there that have these vulnerabilities. And so this is going to be a heyday for spoofers. So now, instead of having to find a vulnerable network, a hosting company that will allow you to send spoof traffic, now anybody can send spoof traffic from any IP address. And as an attacker, you don't have to keep sending the spoof traffic to just one vulnerable devices. Since there are these 2.3 million vulnerable devices on the internet, you could send spoof traffic to each one of these different hosts, and the likelihood of getting caught goes down even more, unfortunately. So here's how to find out if you have devices that are vulnerable. As I said, Shadow Server has this free report. They will tell you. NetScout is a company, and they have DDoS detection mitigation services and appliances, and they realize that this is such a big vulnerability that even if you're not a customer, you can contact NetScout and they will give you a free report to identify what devices on your network are vulnerable. I created a script. I have my GitHub link there for the script, and so you can use that to test to see if your device is vulnerable or not. And I also created a tool that I call Tattletale that uses the Elastic, the elk stash, the elk. It's like Elastic Logstash Cabana. Sorry. And so these are scripts that integrate in with that to and then it uses FileBeat to collect NetFlow data, do the analysis, and look for spoof traffic. And if it identifies that there's spoof traffic, then it puts the information into the Elastic database, and then you can go through the Elastic database and view, when this spoof traffic is coming in. It allows you to trace it back and see, like, oh, it's came from this peer of mine, this other network. They keep sending me spoof traffic. So that's a free tool that's available that'll help you identify that spoof traffic. So what do you do if you're vulnerable? You can contact the vendor. The vendor should have a patch for this. Also, you can apply an access list to block unwanted tunnel traffic going to your devices with your devices as the destination. I have an example ACL here that's in the slide. Some other things that you should be doing, you should prevent spoofing coming from anywhere on your network. So if you, normally we have these filters to prevent spoofing from the edge, from our devices like laptops that are directly connected, but most networks do not have the filters preventing the routers from doing spoofing. And so I think that is why this is such a big vulnerability, that like all these networks that are doing a good job preventing their customers, the edge devices from generating spoof traffic. That's great, but they didn't think about the routers. And so now there are all these vulnerable routers that are in the middle there in the network that can generate the spoof traffic. And so you also need to be looking for this spoof traffic with NetFlow and using tools like that Tattletale tool that I have. So you may think that you're not vulnerable. You're like, hey, we don't even have any kind of tunnel configuration on any of our routers, so we're good, right? Wrong. The routers are trying to be helpful, and when they get a GRE packet or IP and IP packet, they de-encapsulate it, just trying to be helpful. Even if there's no tunnel configuration in the routers, they're still doing the de-encapsulation. So that's a big issue there. So yeah, that's the reason that you need to have these access lists. You need to make sure your routers are patched, even if you don't have the encapsulated traffic, any kind of tunnel configuration in your router. So, this being DEF CON, I was like, okay, what kind of interesting hack can I do with this? And so, man, I wish I could present this, but I'm just gonna have to describe it to you. So I call this around the world in GRE packets. So what if you took this GRE packet, say I started with a ping to Quad 8, to Google Quad 8, and then I put that into a GRE packet. And then I put it into another GRE packet around that. And then I put another GRE packet around that, and another one, and another one. And I was like, okay, well, how many of this can I do? So I was able to do 61 different packets, encapsulations. So this packet that I sent out, it went from this virtual machine, I think in Linode or something like that, went out to one of these vulnerable routers, got de-encapsulated, sent to another vulnerable router, and went back 61 times until the last router de-encapsulated it, sent the ping to Google, and then Google sent the reply back to me. So I was kind of amazed by that. And so I thought that was a really neat hack, and I was going to do a live demo of it. Yeah, the limit there was 61 packets because that was like 1480 bytes or something like that. And so if it got any bigger, then it would have to get fragmented. And I didn't do any fragmentation. Theoretically, you could make it longer. Might be interesting to give that a try, but it was it was just really something for fun, just an interesting hack of this vulnerability. So this is the slides here talking about that interesting hack there. And so coming to the end here, I really want people to realize that this is an important vulnerability that attackers are going to start to abuse. We haven't really seen too much of it in the wild yet, and it's kind of difficult to identify when it actually happens because of that difficulty in doing the traceback. But this vulnerability, it can be used for a lot of different things other than just doing the amplification. You can do like access list bypass. So let's say especially for SNMP sets. So a lot of, SNMP is UDP, it's stateless. And so, we put these ACLs on our routers that say, hey, only allow SNMP from these source IPs. But with this tunnel vulnerability, you can put a private IP address in there and get past that ACL. So that's a big issue there. I know that there are certain nation states that were doing SNMP sets to do TFTP copies of the config. So that is a serious issue there. Also, you could do direct path spoofed attacks with this vulnerability and then hide the true source IP. And then also you can do corruption of logs. I know there were a lot of people, their like SSH servers, I think were getting blocked because people were sending spoof traffic to their, from certain source IPs. It was going to these SSH servers, and then and they're like, I think they were using something similar to like fail to ban that was saying like, oh, that's a bad IP, I'm going to block that. Well, using this, you could spoof from any source IP and theoretically, corrupt logs or get hosts on blacklists like that. And that's the end of my talk. Does anybody have a question? Yep. So, yeah. So the question is, do the vulnerable hosts they have to be on one of the routers that has the vulnerability? Is that your yeah. Yes. Yes. So yeah, the vulnerable routers, they have this this tunnel vulnerability, and they are allowing spoof traffic out. So they may be doing a good job of preventing their customers and other edge devices from sending spoof traffic, but a lot of networks, I would say, maybe like 90% of networks are not thinking about that spoofing coming from the router. So that's I think where the biggest issue is. Yep. Any other questions? Oh, I'm sorry. Yep. An ID for the vulnerability. Okay, yeah. The question was, is there an ID for the vulnerability? And like the network connection here is shit. But I can tell you, it's it's a vulnerability, I would say, because even if there's no configuration on a lot of these devices, they will still do the de-encapsulation, and they should not do that. Like, yeah, and they should be checking to make sure that the GRE IP address, whatever tunnel IP address it is, that it's that they're supposed to de-encapsulate it. They're just like, the routers are like, they did a bad job of programming, and they were like, well, we'll just let any IP address, as long as it comes in, okay, we'll do the de-encapsulation on it. It should be like just certain source IPs that have been configured that it should de-encapsulate. So the vulnerability is called Haunted by Legacy: Discovering and Exploiting Vulnerable Tunneling Hosts. So if you Google that, like Haunted by Legacy Tunnel, something like that, it will come up that way. I think there are numerous CSVs. I think there are maybe like 3 of them, 4 of them, something like that. Okay. Anybody have any questions? Yep. Yeah, that's a good question. I believe, does anybody know so the question was, where are the slides going to be located? And I don't think I've ever looked up slides on like presentations that have been on DEF CON other than on YouTube, but I'm pretty sure this is not going to be on YouTube. So if anybody knows, like maybe where the slides are going to be.
There'll be the slides in the recording, or if you make them available to people, I don't know where you make them.
Oh, okay.
Like, just get them.
Yeah. I could actually make the slides available. I could share it. Like, if you want to give me your email address or some contact information, or anybody, I can send it out to you. That's no problem. Oh, yep. I'm sorry, I'm having trouble hearing you. Like, you're asking about the ACL bypass, yeah.
So, does the router look to what the IP addresses in all the encapsulations, or just the complex?
Okay, yeah. So the question was about the ACL bypass. So normally, say with like an access list that you would put on your SNMP server on the router, you would say like, hey, permit from these source IPs, and then deny from anywhere else. So it has to be sourced from certain source IPs. So the attacker would need to know one of those source IPs. They could try to enumerate through and just keep doing SNMP queries, SNMP sets to see if it gets by. But yeah, that's normally the way that the ACL is configured. Does that answer your question? I'm sorry.
On different encapsulation.
Oh yeah, 61. Yeah.
So if any of these IP addresses that 61 list is matching the accessibility.
Oh, no. Okay. All right. So that 61 number. So that was a just kind of a hack that I did just to see what would happen if I took a GRE packet and put it inside another GRE packet, inside of another GRE packet, inside of another one, and sent it to these vulnerable routers around the internet, and see if I could get my ping back. And I was able to do it. Sometimes it took like I would have to do it like over and over again until I got my ping back and select like different hosts. But yeah, that was just kind of a fun hack that I wanted to share. Just show how you could take advantage of this vulnerability. Yep. Yep. Yeah, so that question was like, do the large number of encapsulations help with spoofing? I guess it could. You could like make this sort of like jump around the internet, so it's even harder to track back. Because if you do like, if like, let's say a researcher is figuring out like, oh, this guy is sending spoof traffic and it's coming, from here and it's going from this router. But let's say that you do this multiple encapsulation, then your packet is like jumping all around the world before it gets de-encapsulated. So it makes it exponentially more difficult for the defenders to figure out where it's coming from. It's kind of like, say if you're a hacker, you have multiple servers that you've set up that you bounce from, and then you do your attack. You don't do it from your local computer. You jump from host to host to host, and then you're like, okay, I'm in Uzbekistan, and I'm going to do the attack from there. Then if they figure out like, oh, let's trace back to that, and then yeah, it just makes it much more difficult. So yeah, you can do that with this encapsulation. Yeah. Yes, exactly. Yeah, so yeah, the person in the audience is saying that like, hey, you can change the IPs around, change the encapsulations, and yeah, that's interesting. I didn't really think about that. Is that you could have like GRE inside of IP and IP inside of another protocol, and yeah, that's definitely something that I believe you can do with this vulnerability. Cool. Anybody else? Going once, going twice? Okay. All right. Thanks, everybody.